Hello. In this video, we are introducing a third way of finding the volume of a solid. And this is another method for a volume of rotation. So suppose we have some function similar to maybe a quadratic function or maybe a sine function or something that's just coming back down, repeating on itself. And we want to rotate around the y-axis. Well, the discs and washer method told us we needed to slice perpendicularly to the axis of rotation, which means when we would find this volume of rotation based on those slices, we'd be having to solve for the left-hand side of this curve, the right-hand side of this curve, so we could subtract them as a big radius and a little radius. And some functions, that's really not easy to solve for. So this is where this last method, the cylindrical shelves method, comes in and says, suppose I'm going to go around the y-axis, and it's not easy or possibly even impossible to slice perpendicularly to the y-axis. So let's say I want to slice parallel to the y-axis. We're still getting this 3D shape, kind of like a bundt cake shape in this example, where there's this little hole in the middle. And we want to figure out, is there a way to take those perpendicular slices, those parallel slices, and create a volume? Well, if we look at one of these slices, it's being sent all the way around, hitting the other side and back. So looking closely in at just that blue part, which I'll erase to clean up this picture a little bit. Looking in at just that blue, it is creating a cylinder shape. Like if you took a piece of paper and rolled it up into a cylinder. And we know to find this outside part of the cylinder, if this is just a piece of paper, we're taking a piece of paper rolled up into a circle with some height. So we have a height and we have the radius, 2 pi r, giving us the circumference. And if I unrolled this piece of paper, I'd be getting a flat surface. Yeah, the base is that 2 pi r distance, and the height is the same height. And the area would then be 2 pi r times h. We can think of this whole stretch being made up of those rolled up pieces of paper. Think if you take a piece of paper and roll it up real tight, eventually starts making like a log shape. The same thing is happening here. So if we take the integral of this, we'll get a volume. Volume equals 2 pi r h from a to b dx. But what is r and what is h? Now remember, this is coming back from a cylinder that's based around the x-axis. So r is however far out from the x-axis I am, or another way of figuring out where am I from the x-axis is the x-coordinate. So r is x. And the height of this was defined by a function. So h is whatever function of x is being sent around the y-axis. So h equals f of x, creating this integral, the integral from a to b, 2 pi x, f of x, dx. Now we have a formula we can use known as the cylindrical shell method. So let's take a look at an example. Cylindrical shell method. We want to find the volume bounded by rotating the region bounded by 4x minus x squared and y equals x about the y-axis. So the volume using the cylindrical shell method is a to b 2 pi x f of x dx. And what these areas look like is we have the quadratic between x and 4, and we have the line y equals x. So we're taking this area and rotating it about the y-axis. So we're creating, kind of similarly to one of the last problems, a cone-like shape on the outside with these curved inside edges going around the y-axis. In a previous problem, we saw these functions exactly, and the intersections are at 0, 0, and 3, 3. You can find that by setting 4x minus x squared equal to x and solving. But once we have that, it is now a case of setting up our integral. However, we have two functions. We have 4x minus x squared and y equals x. If we go back to the definition, that function was representing a height. So what really that function is saying is the height of whatever these slices are. And in this case, it's going to be our parabola minus our line. So volume, or h, should say, h is going to be the parabola for x minus x squared minus x, or 3x minus x squared. And the radius, well, we're still going around the y-axis, so the radius is x. Our volume integral is the integral from our intersection points, between our intersection points 0 to 3, 2 pi x times 3x minus x squared dx. Or the integral from 0 to 3 of 2 pi times 3x squared minus x cubed dx. Integrating this, we get 2 pi of x cubed minus 1/4 x to the 4th, evaluated from 0 to 3, or 2 pi times 3 cubed minus 3 to the 4th over 4 minus 0 cubed minus 0 to the 4th over 4. Evaluating that out works down to be 27 pi over 2. And that is the volume of our solid formed when rotating this region around the y-axis.